Okay, lesson 2-3 standard form. ax plus by equals c. This is the standard form for linear equations where a, b, and c are integers. So what does that mean? That means that a, b, and c cannot be a fraction, cannot be a decimal. It can only be positive and negative whole numbers. Occasionally you will see a zero, but for the most part, whole numbers, negative numbers, but no fractions or decimals. What does that mean for you in graphing? These are not points. Don't write them as points. This is not a slope. There is no rise over run. This is not intercepts. These are not the points where it crosses the axes. So you kind of this is special. For a linear equation, this is different from slope intercept and point slope. Okay, so you need to be aware of that. So we're actually going to start with a word problem for this. Okay, so for the word problem, Hannah will spend $150 on music on a music festival. Reserved seats cost $25 and general admission tickets cost $10. How can you represent a situation with a linear equation? Okay, so she's going to spend 150 bucks. So let me just write down this information. So $25 is reserved. I'm put R for reserved. And then $10 for general, gen. And she's going to spend a total of 150 total. So that's the information I have. Now, this is very important. Your total is always C. So if you're going to write this in standard form, you're going to make it equal to 150. That is your C. Okay, so that means you need an AX plus a BY. All right, so you have to know what X and Y are. Now, X and Y are the things that you're trying to figure out. Now, what things are you trying to figure out in this problem? The number of tickets that she can buy. There's two kinds of tickets. There's reserve tickets and there's general tickets. So if this is X and this one is Y, the price of those tickets would go right here. And there is your standard form of the linear equation. So $25 for each reserve ticket plus $10 for each general ticket will give you a total of 150. And guys, that's standard form. So this is what I mean that there is no graphing this the standard way. You kind of have to take the information given and write it as best you can. Now, if you're going to graph it, we have to turn this into y equals mx plus b. That's our best chance. Okay? So let's talk about how we do that. How do we rewrite this to make it look like y equals mx plus b? So let me write it over here. 25x plus 10y equals 150. All right. So what we have to do is we have to make it equal to y. We have to solve for y, which means this needs to be by itself. We have to cancel out the 10 and the 25x. So step number one, let's get rid of 25x, and then after we do that, we'll get rid of 10. But how do you get rid of something? With inverse operations. Whatever you do to one side, you do to the other. So if I do this, and I move that, you're now going to end up with 10y equals negative 25x plus 150. They don't mix. This is a whole number. This is a number with a variable. It has an x. That one doesn't. So the only thing you do is write them together on the same side. Now I want to make it look like mx plus b, so I put the number with x first. Next, gotta get rid of that 10. That 10 is multiplying. Inverse operation is divide. Now when you divide, you don't just divide one number, you divide all the numbers. So if I divide that, the 10s cancel out. I have y. I have negative, I'm going to simplify this. 25 divided by 10, if I divide it by 5, I get negative 5 over 2x plus 15. And there is slope-intercept. So I took standard form, and using inverse operations, I turned it into slope-intercept. Now I could graph it if I want. And that's it. That's how you transform it. Okay? That's problem number 1. Let's move on to problem number 2. Actually graphing it. So let's practice what we just did. Let's graph this. Okay? So there's 2 options that you have for graphing. Option number 1 is turn it into y equals mx plus b. So I'm going to take the same thing I did before. I'm going to solve for y. So I'm going to do move the 3x, minus 3x to both sides. And then again, they don't mix. I just write them together. I need to divide this by -2, but I divide everything by -2. So this cancels out. This becomes a positive. And this becomes -9/2. Now, if I'm going to graph that, I want to turn that into a mixed number or a decimal. So if I divide it by 2, I get -4 1/2. Okay, so that's where you would graph it. You would take this information and graph it. Okay? So just to kind of review with you what the graph would look like. -4 1/2. So in my graph, I would have to find 1, 2, 3, 4, 5. This would be -4 1/2. My slope is 3/2, so I'm going to go up 3. 1, 2, 3/2. My line would look something like that. Now, that's one way to graph it. There is another way to graph it using the intercepts. So I'm going to show you that now. So if you want to solve it like this, you can. This is the other way you do it. Intercepts. So intercepts, guys, if you remember, is where it crosses the x-axis and the y-axis. So here's what you do. You basically ignore one of the variables. So just, let's say I ignore this. I get that problem. And let's say I ignore this one. Okay, how am I able to do that? The only reason you're able to ignore something is if it's 0. Okay, so that'll make sense in a second. Now, if we solve one at a time, I'm going to divide both of these by, this one I'm going to divide by -2. I'm going to get -4.5. This one I'm going to divide by 3. I get 3. Now, here's what just happened. If I make coordinates, right? If I make an x and a y, when you do an intercept, one of the numbers is 0, and the other number is where it's crossing the x-axis. So when you ignore x, you're basically saying, what if this is 0? If this is 0, then 4.5 has to be y. But here, if y is 0, and I ignore this one, then x has to be 3. Okay, so what does this do? This now can be graphed. Because what you have is you have the y-intercept at 1, 2, 3, 4, 5, at 4.5, and you have the x-intercept at 3. 1, 2, 3. And then you draw your line. So you get the same line, but with 2 different methods. So you can either change it from standard to slope-intercept, or you can solve for each one separately. Solve for x and solve for y, and treat it like intercepts. All right? Next, number 3. graphing when there is only an x and a y. Now listen, if there's only an x and a y, you don't have to ignore anything because there's only one thing for you to solve. So if there's only one thing to solve, you just solve for that. So in this case, I'm going to solve for x. So I divide by 4, and I get x equals 3. Now, how do you graph that? Well, remember how we said you have an intercept? This is your only intercept. If you wrote this as a point, that means that the point would be x is 3, y is 0. So 1, 2, 3. Because you cannot solve for y, there is no y-intercept. Now this is where it's kind of weird. Because if you draw a line like this, it's going to cross the y-axis. If I draw a line like this, it's going to cross the y-axis. If I draw a line like this, it's going to cross the x-axis. The only way there is no y-intercept is if your line goes this way. It's vertical. When there's only an x-intercept, it only goes through that line. It's going to be a vertical line. So if it's like this, if you're solving for y, and you get y equals -6, this coordinate, where there's no x, would be like that. Now if you graph this one, 1, 2, 3, 4, 5, 6. -6 right there. There's only going to be a y-intercept. It will never cross the x-axis because there is no x-intercept. Then your line looks like this. Horizontal. So whenever you only can solve for one point, you either have a vertical line or you have a horizontal line. And it all depends on if you have a y-intercept or if you have an x-intercept. Okay? So last one, last word problem, example number 4. Okay. So for example number 4, Tamira is making trail mix. She has $40 to spend on a mixture of almonds and cashews. She wants the same amount of almonds as cashews. How can she determine how many pounds of each nut to buy? So they cost different prices. If you look at the information right here, they don't cost the same amount. So we need to figure out how much they would cost. All right, so let's start with the equation. We're going to write it in standard form, because what they give you is how much she can spend on making this, the total amount that she can spend. And that number is 40, which means that the almonds, we'll make the almonds represent X, and we'll have the cashews represent Y. So it's $8 for the almonds, so I'm going to put 8X, and it's $10 for the cashews, I'm going to put 10Y. And ladies and gentlemen, this is the standard form of that equation right there. There it is. Now, how can she determine how many pounds of each kind of nut to buy? So, to do this, what we're going to do is we're going to turn it into a linear equation. All right? Or you know what? No, let's go with what we've been doing. Let's keep using intercepts. So, I'm going to solve for each one separately. So, I'm going to ignore X. Sorry, I'm going to ignore Y and solve for 40. And then I'll ignore X and solve for Y and solving 40. So I'm going to get my intercepts, okay? Divide both sides. Here, X is 5. Here, Y is 4. Now, these are two different points because they're intercepts. This point, you ignore the Y, so the Y was at 0, it's not there. Here, we're ignoring the X, so the X is 0. And we have this. Now, if we graph this, okay? Let's graph this. Sorry, I wish it was more straight. I apologize for my bad drawing. Now, if we draw this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. What am I graphing? Well, remember I told you we labeled X and Y. X is almonds, and y is cashews. Okay? So what do these points mean? Well, let's take this point, 5, 0. 5, 0 would be 1, 2, 3, 4, 5. Right here. And let's take 0, 4. 1, 2, 3, 4. These are your options for what she can buy. What does that mean? Well, guys, here, if she buys 5 almonds or 5 pounds of almonds, she can't buy any cashews. And if she buys 4 pounds of cashews, she can't buy any almonds. She's trying to get an even mixture. So we want to get something in the middle, like right here. So something like 2, and I guess 2.5, like right there. 2.5 and 2. That's pretty even. That's a pretty even mixture. Okay, so this would be a good answer for trying to have an even amount of both kinds of nuts. And if I wanted to test it, I can take this point and see if it works in the equation. So here's what I mean. You would take 8 times 2.5, 10 times 2 equals 40. And you would see if this would make 40 bucks. Okay, so I would multiply that. So this would be 2 times 2.5 is 20. And then 10 times 2 is 20. And that would make 40. So yeah, if she buys this amount, she buys a little bit more of the almonds, but pretty even amount. I'm going to go with that answer.